Friends, welcome back to Cyberscripters. In this session of Python learning, we are going to learn about object-oriented programming in Python. So, object-oriented programming is a programming paradigm, or you can say concept, which can be implemented in any language that supports objects or object-oriented programming. For example, this can be implemented in Java, C++, Python, or any other language that can support object-oriented programming. So there are two things. One is the theory part on object-oriented concepts. So basically, you would need that thing when you want to design something in using objects. So that is generally called object-oriented analysis and design (OOAD). So that is a separate subject and requires a separate in-detail discussions of class and designing of class and other things. But what today we are going to discuss is we would be looking at how this object-oriented programming can be implemented in Python. I will be giving you overview on objects and instances and classes, but if you need a detailed understanding of this, just let me know. I'll create a separate video on it because that would require a separate video about an hour just to explain object-oriented programming design paradigm. Okay, so let's just move forward. Okay, so first thing is why do we need object-oriented programming? Why can't we do everything in the procedural programming? Yes, we can achieve everything by procedural programming, but there are certain things that if implemented using object-oriented programming would be much easier and would be more secure. So we already have primitive data types in Python like integer, string, float, but they can store straightforward information such as cost of something or name or a string. Let's say you have a requirement to store something complex. One example is you want to store details of all the employees in the organization. Now your organization could have 50 employees or your organization can have 500 employees, right? So first thing is whatever solution you are choosing that should be scalable. Okay. And for each employee, you will have to store a number of attributes like his name, age, date of birth, address, joining date, his designation, his location, his salary, his educational qualification, the city he is living in, and there could be n number of things that you would be tracking just for employee. So one way to do it is you create list for every employee and you store the data like this. So the name of the employee, then his age, then his designation, then his employee ID, and so on. And then you can have a dictionary and you can have something unique like employee ID. So employee ID is unique for each and every person. So what I can do is I will use employee ID as the key and the list for data. Now you can store this information this way. But then there are some issues with this. For example, one is let's say you are storing educational qualification. Now somebody would be having 5 degrees, somebody would be having only two, somebody would be having seven. So it would be very difficult for you to track those things just using the ID. So again, you can use a dictionary within a list and you can do it. But that would be very complicated. So for such data, the best way is to use object-oriented programming. In object-oriented programming, what happens is you have a class, and that class would encompass all the attributes and the methods that can act on those attributes. So let's say if I have a I for in our case we are taking example of the employee. So I can create an employee class. I will create all the attributes like ID, name, address, his education qualifications, and whatnot. So all the attributes can be defined here. And then all the methods that are required for this employee class would also be implemented in this class. So it is a package basically. So this is a data type. This is sort of data type wherein you have all the attributes and the methods bundled together. Okay, so we already started talking about class, but then let's understand what are class, what are objects, and what are instances. So I have seen many people, even some of the experienced people, getting confused between class, objects, and instances. So when you say class, class is just a definition or a blueprint, right? So you see here in the blue on the top right, you see this is the definition of a class. So this class is called animal and it has three attributes: type, gender, and age. So what I am basically storing is I have created an animal class that stores three things: what kind of animal it is a cow, is it tiger, it is lion, or what it is. That's the first thing. Second is what it is age and what it is gender. These are the only three attributes I am interested in. I'm not implementing any methods for now. So this is an example of a class. Now you can relate this with a blueprint of a house. So for example, you want to create a you want to develop 10 houses. You want to develop a housing society with 10 houses in it. Now you want every house to be exactly similar. So what you would do? You would create a blueprint first. Like there would be two bedrooms on the ground floor, maybe three bedrooms on the top floor. This size would be kitchen. There would be three bathrooms. The staircase would look like this. So everything would be created on a paper first. That is the blueprint. So that is your class. And then when you create actual houses out of it, those would be your object. So in our case, this is my class. Now, how do I create an object out of it? So to create object out of it, you have to call constructor. So just don't worry if you don't understand what a constructor is. We'll look into PyCharm. At that time, I'll explain. But a constructor in Python looks like something like this: underscore underscore init underscore, and then you have variable called self, and then all the attributes that your class would like to have. Now, when you want to call it, when you want to create object out of this class, you call it like this. You don't call this init method. What you do is you call this class animal and you pass all the required parameters. So these are three attributes that this class supports. So I will be passing. So in this for this object, I am passing cow, female, and 15. So what it would do, it would create an object in memory, and for that object, it would have type as cow, gender as female, and age as 15. So my first object is created. Now I have created second object. Again, I would call animal. Now this time I am giving tiger, male, and age as 5. Second object is created. Third object. So I can create as many objects I want. So let's say I have an organization with 500 employees. What I can do, I have created a class called employees. For each employee, I'll have to call this constructor with all the required details, and an object would be created in memory. Now, next time when I want to access that particular object, I just need to pull out that object and use it. And all the required attributes and methods related to that particular object would be available to you. For example, you use string, right? We have so many methods in string. We say string dot upper, string dot lower, right? So When you put a dot after your string variable, you see list of methods that is shown. That is because those are implemented in string class. And the string variable that you are using is an object of that class, and that's why you are getting those methods. We'll see exactly how it is done. Okay, so I told you about class. Class is the blueprint, and this is the class. Object. So object is when you actually create house out of that blueprint, or you call a constructor in case of Python or programming language. When you call a constructor, you get an object. Now, what is an instance then? So instance is basically the object that you currently are working on is called instance. So for example, you have created 10 houses. The house that you are currently working on, right? So if I am working on house number 5 right now, that becomes my instance. So whenever you are working on any object, you would access these attributes using self dot name, self dot type, self dot gender. So self is the instance. Basically, the object that you are working on becomes self, and that is an instance. So we'll look into this. Okay. Now next is function versus methods. There is no difference between a function and a method. We have seen functions. Those functions, when implemented within a class, they are called methods. The only difference is when you define a method within a class, self object, self is passed as a parameter. So we'll see again when we go to PyCharm, when I define a method and when you press enter, there would be this self always would be there. If self is not part of the parameter list, then that is not a method, then it is a function. We'll see that difference as well. Okay, the other difference is only objects can access methods. So for example, I have employee class and I have implemented three methods. So only employee objects can access those methods, nobody else can. Right? For example, you want to call upper method on string. Can you call it on integer? No. Can you call it on float? No. Can you call it on boolean? No. Why? Because only objects of string class can have access to those methods. So only string objects can access this methods. So that's why when you have something a string, some variable x is equal to, let's say, Python in double quotes, a string, and you say x dot, you will get all the method that only string object has. So now let's go to PyCharm and see how classes are implemented. Okay, so now let's go ahead and create a new file. Let's say I want to name it as Object Oriented Programming Basics. So let's define a class. So this is how you define a class in Python. Let's try to run this first. So see, this is the simplest definition of a class. Just the class name, nothing else. This class is of no use actually. The class is only useful when it has some attributes and methods in it. So let's just go ahead and define attribute. So first thing is you need a constructor. So this is the constructor. This is how we define a constructor in Python underscore underscore init. And this is a default parameter to this method. So all the methods would be having self. This is what I was talking about. As soon as you define this function within a class, it has self in it. So now what I would do is I would create two attributes. Let's say this person has name and age. Rest of the definition is just like a function. The only thing is the attributes have to be accessed using self dot. So what I have done here is I have created a class called person with two attributes, name and age. Let's run it again. Nothing happened. The object is created. Now let's define a method on top of this. So let's say I want to check if this person is minus. See, as soon as I type this opening bracket, it takes self by default, this editor. Because if you are writing some method in a class, it should have this self. Now let's say if x is equal to true if self dot age is less than 18, else false. Return x. See, this is more like a normal function. But the only thing is, here I mean self.age. What does it mean? It means that the object that is calling this particular method, it would take age from that object only. Let's see how it happens. Now I have defined my class. So this is the class. Now, this class is of no use unless you create an object out of it. Unless you put some values into name and age, this is of no use. So now let's create an object. How do you create an object? So I say variable p is equal to person, and this is how you create an object. So now let's say, let's say I have created an object now because what I have done is I have given a value to name and a value to age. Similarly, I can create as many objects as I need. So now we have created three objects. First object P, second object P1, this is P2. Now let's say if I want to call a method on this, so I can just call. First, let's create a display method. What we have said, def display, sorry, display print f name self dot name and age. Well, let's just go ahead and display this. So that would make these things clear why we need to pass self. So what is happening here is when I say p dot display, see this display is taking parameter called self, but we are not passing anything. Shouldn't we be passing anything? No, the self should not be passed. What happens is when you call p dot display, this object p is passed as self. So now when I say here self dot name, it actually is p dot name and p dot age, whatever we have set it. So let's just go ahead and see it. See, if I say P, it would be Rakesh and 35. If I say P1, it would give me P1's object details. So what is happening actually? So the object that you are using to call that method is passed. So when I say P1 dot display, I don't need to pass anything because P1 is passed here, and now it knows P1 dot name and P1 dot age. What is it? So if you have 50 parameters or 50 attributes for an employee of an organization, you don't need to pass anything because the methods that are going to implement these things, or a method that are going to use these variables, they know everything about that object. Now let's see, is minor. So I can say print p1 dot is minor. See, I'm not passing anything. I don't need to pass anything into this function because I am using this function on an object, and that method would take that object's attributes and would return me values. So see, it is getting false. Now if I do p2, let's call p2, it is true because p2 is minus. John is only 10 years, so he is minus. So this is very basic understanding of, this is the basic understanding of an object and class. Generally, you could have n number of attributes, and you could have n number of methods, but your class would always look like this. You could have complicated methods, you could have complicated logic running into the methods and using those attributes, but if you understand this basic thing, that a class has attributes and it has methods. This is the basic thing. Now let's go a step further. Now, whatever you are defining in init method or constructor, they are called instance variables. So these are instance variable or object variables, you can say. So every object will have different of this, or every object will have a copy of its own. I can create two objects using the same data. That is not a problem. But these are object specific data. Now, if I define some variable here, like let's say number of person objects. I want to count how many objects are getting created. So now this particular variable is a class variable. It is not an instance variable. This is called class variable. So what happens is, whenever what happens is whenever a constructor is run, I want to increment this by one because I want to keep track how many objects are getting created in memory. So you see, I cannot call it using self because it is not an instance variable. It is a class variable. So I have to call it using class name. And all the objects, all the objects that are in memory, that the person objects in memory would be sharing this number of person. So now let us run the same program and see print this variable for all our objects. So this is person dot number of, so I'm calling it on class. I would be calling it on objects. Oh, it's not kept. Sorry, my bad. Now see what happens here is this 4, 4, 4. These are the three lines. So whether you access this particular variable using class name or object name, it doesn't matter. It would give you same value because this particular variable is a class variable and it is shared among objects. See, this particular thing, name and age, they are not shared. They are different for each object. But this class variable is shared between the objects and it would be displayed as same for each of the objects. And this is how you can do it. One way of doing it. Now, similar to class variables, you have class methods as well. So how do you define a class method? So let's define a class method. So for class defining class method, we will be using a decorator called class method. Now, what is a decorator? You don't need to understand right now. Right? We will be looking in the later chapters what is a decorator and how to use it. But for now, you have to be with me and assume that you put an at the rate and a name class method. Now, this is how you. So I want to display total objects. Now see what is happening here. As soon as I say class method, it is not passing self, it is passing CLS. So that is class. A class is passed. Now here I can say print total person objects created are. Now we saw outside the class you can access this variable using class name, but here that class name is passed as a parameter. So you can use that. So now let's do print person dot display total objects. See again the class parameter I don't need to pass when calling that method. It would do it automatically for me. See, sorry, we are passing a print. We don't need to do that because we are already printing it there. Okay. So see what is happening here. What I'm saying is you have a class variable and you have instance variables. Instance variables are unique for each object. Class variables are shared among all the objects. Similarly, you can have class methods as well. Generally, the class methods are used in factory methods. So there are some design patterns. In design patterns, we have something called factory design. In factory design, you are not allowed to call a constructor directly on a class. But some other method would return you the object. For example, here we have only two attributes, right? Name and age. Let's write a one more class method. For that, we would need date. So let's just go ahead and import from date time, import date. So we would be using this in our next. class method. So again, for class method, you just use the decorator, and I am using this to calculate age from birth year. So I would say def calculate or create object from birth date. So now for this particular person, I don't have his age, but I have an year. I have his birth year. So I want to create a object out of it. So what I can do, I can say return CLS his name, and let's just go ahead and calculate it the age from the year. So I would say date dot today dot year minus year. So this would give me his age. So what we are doing is basically we are calling a method, a class method. From class method, I am calling the constructor. So when I call the CLS method, it is actually calling constructor or the init method of the person class or the class that is calling this method. And what we are passing, we need two attributes, name and age. So I have name, age I am calculating from the year. So let's just go ahead and do it. So I say P3 is equal to person dot create object from birth date, and I am saying Vijay, 25, and let's just say P3 dot display. See, we have created, sorry, we need to pass here is birth date, right? So let's just go ahead and say born in 2000. So see now, what we have done here is basically we have created a class, we defined instance variable, we defined methods, we have defined a class variable, and we also defined a couple of class methods. One of the class method was just used to access the class variable, while the other class method we actually used to create an object out of it. So this is all about a class and how you can define a class, what are the class variables, what are the instance variables, and how can you define class methods. Now we'll look at inheritance and abstraction. So there are some basic benefits of object-oriented programming. One of them is inheritance. Let's look at inheritance now. Okay, now let's look at another important feature of object-oriented programming that is called inheritance. So now what is inheritance? So inheritance allows us to define a class that inherits all the attribute and methods from another class. So what happens? You have class A. Now you want to create class B, but you want all the attributes and methods in class A to be part of class B. So that can be automatically done using inheritance. Now why would you need to do that? Let's say I have an employee class. I have, let's say, 10 or 15 attributes defined for employee, and then there are some methods also defined there in an employee class. Now I want to create a manager class because manager is already an employee, so he needs to have all the attributes of employee. So I can do two things: either I can rewrite all the attributes and methods again, or I can just inherit it from employee class. So what I can do is when I'm writing my manager class, I just extend my employee class. We'll see how to do that, but you need to understand that when you say inheritance or when you have some class extending some other class, basically that inherited or the derived class gets all the attributes and method defined in the parent class. So we have two kinds of inheritance. One is single inheritance. So you have an employee class and then you create a manager class. Or you have multiple inheritance wherein you inherit from multiple parent classes. So for example, there is a class called person, there is a class called employee. Now when I'm defining a manager, so manager is an employee, he is a person also. So I want to inherit methods and attributes from both the class. So that also can be done. Now let's go ahead and see how that would be implemented in Python. Let's go to a Python. Okay, we'll create a new Python file, or that we'll call this OOP inherit. Okay, so to understand inheritance, let's just create a class called person first, and let's define our constructor. And let's say person has two attributes. One is he has a name, and let's say he has an ID. So ID is some sort of unique ID. It could be PAN card, Aadhaar card, social security number, anything. So name and ID. And let's just write a method display print name column name, sorry, self dot name, and ID is self dot ID. Right? Let's just create an object and see if this works. So P is equal to person job, let's say 25, and let's see P dot display. So we have created our person class. It has two attributes, name and ID, and it has one method, that is display, and we executed it. Now let's say I want to create another class called employee. Now the employee is already a person, so he should have all the attributes and method that a person has, right? So what? Let's go ahead and define our employee class. So I can say class employee. Now I want to extend it from person. I want employee to inherit all the attributes and methods from person. So I need to tell it this way. So in bracket, you say person. So what it would do? Let's say we don't do anything here, right? Now, instead of John, I say E is equal to employee test 1 and 25, and I see 23. See, we have not written any code into employee. There is no code into employee, but still it behaves as my person because it is inheriting all the attributes. So when you call employee and test one, basically what is happening? It does not have a constructor. We do have not defined init here. So if you have not defined any init here, init of the parent class would be called. So person's init would be called and it would pass test 1 and 25 here. And name and age would get initialized. Now let's say I define a constructor here now. And let's define few attributes for employee now. On top of name and age, let's say I say company name, salary is equal to salary, and self dot designation is equal to right. Now see what happens. So company name, salary, and designation. Now let's see. Let me run the program once again. Now I am getting error. Why? Because what is happening here is this requires three attributes. We are passing only one. So now let's go ahead and pass our required attributes. So company name is ABC Corp. His salary is let's say 50,000 and designation is manager. Now let's see what happens. Now what happened was, see, we passed these three things and we call display. Now what display is doing? Display is printing name and ID, but employee does not have name and ID. Why? Because as soon as you run a constructor on a class, right, it has its own attributes. But now it does not have parents attribute. Now, if you need parent attribute, you need to call parents constructor. Now, do you do it? You do it two way. Either you can call person dot init name and ID, or you say super dot. Either way is fine. But now you need name and ID, right? So your employee constructor should include name and ID as well. So now I have to say John 25 or 23. Here to be name and age. See what is happening now. My employee class has only three attributes: company name, salary, and designation. But since we are extending employee class, we need to call employee constructor, person's constructor as well. Now, for calling person's constructor, I need name and ID. So that also should be passed when you call this employee constructor. And you can call either one of these to initialize the parents constructor. Now let's run this program and check what happens. A comma is missing. Again, sorry. Yeah. See now what happened. But this display is not displaying company name, salary, and designation. Why? Because this display is being called. Now I want to display employees attributes as well. So I can what I'm doing is I'm writing a display in employee as well. Print and designation is self dot designation. Okay, okay, done. Now let's see what happens. Okay, so now first we have created person class and we are calling display method of person class and it is displaying name and ID as defined in the person class. Next we define employee. Now my employee class also has the same display method, but when I'm calling employee, this method would be called. My parent method will not be called. If I want to call display method of my parent, what I should do is I should again call super dot display. Now see what happens. Now both the display would be called. So you can either override a parent's method. So for example, if I don't call this, what is happening is my this display is overwriting that display method and it would only print what the new stuff that I want to get printed. But if I want both of them to be executed, then I can call it explicitly using super. So this is how you inherit from one class and create your child classes. Now let's look at multiple inheritance. So for that, let's define a class. Let's say we call it base one, and let's write a constructor. So self.str one is equal to first, and I'm defining one more name field. This is a very simple class. Let's not have any methods for now. We just want to understand multiple inheritance. Let's create a class called base2. Same. Let's say this also has two variables. Let's keep it name only. And third class, let's say this is a derived class. Now I want to inherit from both this class. So what I can do is I say base1 comma base2. This is how all the attributes and method from class base1 and base2 will be inherited into derived class. Now let's say I have a constructor init. Now if I want from this constructor, I want to call constructor of base1 and base2. So I can base1 dot init and base2 dot init. So it would call constructor of base1 and base2 just in case you have different attributes that you want to set there. Let's just have a print statement here. Derived class constructor called so that we know. And let's just another define display. What we want to display is print. So we have two things, right? Let's define printf base one str1 its value. So self dot str1 and base2 dot base2 str2 self dot str2. Okay, so what we are doing here? We are creating a derived class from base 1 and base 2. We have two different classes. So from my derived class constructor, I am calling constructor of both the class. And then I have a display method wherein I am displaying an attribute called name. Now name is a common attribute in both the derived, both the base classes. So my base one also has name and I have same attribute name in base 2 as well. And then I have str1 and str2. Those are two different attributes in both the classes. Let's see how these things print out. Now, let me create an object of derived and let's call d.display. Sorry, we need to pass self here and here as well. Okay, so see what is happening is as soon as I call this derived, my init called. Base1.init was called, base2 init was called, and then our first statement was executed, that is derived class constructor called. You can see it here. Now after that we called display and it printed this. So what is happening here is I'm initializing base 1 first and then I'm initializing base 2. So the base 2 is overwriting base 1. All the attributes of base 1, if they are common between base 1 and base 2, then base 2 would overwrite it. And that's why you are getting base 2 in your name. Now if I just change the order of initialization of parent classes, now what is happening is base 2 is getting initialized first, then base 1 is getting initialized. So base 1 would override base 2. So all the common attributes of base 2 would be overwritten by base 1. So now because we have name common in base 1 and base 2, you see your name attribute is being overwritten by this base 1 class. Now if I again just change this order, I'll get base 2 in name. So this is how you can use single inheritance and multiple inheritance in Python. Okay. Now let's look at abstract methods. What are the abstract methods and how do we implement them in Python? So let's say you have a client server system or you have a web browser that is talking to your server and then server is talking to database. Now you have created a policy that any class that is talking to database should implement or must implement certain security methods. Some security measures have to be in place before you go and talk to your database. So basically, you want to mandate certain methods to be implemented if you want to connect to your database. Now, how can you do that? So that can be done using abstract methods. So let's just go ahead and create a new Python file first. Let's say abstract. Now to create abstract method, we would need ABC import ABC comma abstract method. Now what is ABC? ABC is abstract base class. So if you want to create a abstract class, you will have to extend this ABC. ABC is basically ABC stands for abstract base class. So let's create a class called shape. And because we want this to be an abstract class, it has to extend ABC, right? Now let's define an abstract method. So abstract methods are basically methods without any implementation. Ref area. So I don't want to put any definition here because the definition of area would depend on the shape that is being used. So if you have circle, your area's definition or formula would be different. If it is square, it is different. Rectangle, it is different. So we don't want to implement it here. But what we want is any class that extends the shape class will have to implement this. Let's say I define one more abstract method there. Let's say perimeter. Now again, perimeter also depends on my shape. Now let's create our concrete classes. Let's say we first create a rectangle, and since rectangle is a shape, we want extend the shape class. Let's write our constructor. So rectangle has length, width. So self dot length is equal to length, and self dot width is equal to width. Simple. Now let's see what happens. Let's just go ahead and create an object of rectangle shape. Let's say 1 comma 2. My length is 1, width is 2. Let's just run it. Sorry. Let's just go ahead and run it. It is giving me error. Why? Because I have not implemented the mandatory abstract methods. So this is how you can enforce certain methods to be implemented in the child class from parent class. So now let's just go ahead and implement both the methods. So area would be like length into breadth width. So we would return self dot length multiplied by self dot width. That's it. Now about perimeter. Return 2 multiplied by self dot length plus self dot width. Now let's just go ahead and run it. Now it didn't give me error because I have implemented the mandatory methods. So abstract methods are methods which may not have implementation or at all, or which may have partial implementation, and you want those methods to be mandatory implemented in the child class. So now let's say if I run r dot area, let's print it area. Let's see if I get an area. See, I got an area is 2. 1 multiplied by 2 is 2. Let's define one more class. Let's define class circle, and it should also extend shape. Again, def init. Now, for circle, we just need only radius. We don't have length and width there, so self dot radius. Now, area is equal to, so let's say return pi So basically it is pi r square, so radius square. So we will multiply radius twice. Multiply by self dot radius. Uh, we have different perimeter as well. Perimeter is 2 into pi into self dot radius. So that is 2 pi r. So basically this is pi multiplied by r multiplied by r. Basically this is 2 multiplied by pi multiplied by r. Now let's create a circle. C is equal to circle. Let me pass radius as 10. And now let's say let's print this area as well. So this is C dot area. What is happening? Okay, so now let's go ahead and see what we get. So we got the area of circle. So this is how you can mandate this thing. Let's create one more class just so that things get clear out. I want to call this class as square. Now since square is very similar to rectangle, I don't want to define everything again. What I want is I want to extend rectangle. Now in my init, what I need, see for rectangle, I need length and width. But in case of square, all the sides are equal. So I just need length. Now what I would do, self dot length is equal to length. And then I will call rectangles init method. Now it requires length and width, but in case of square, both are same. So I will pass length, comma length. And my square is done. I don't need to do anything. I don't need to do anything here. Now, since square is not extending abstract class, I don't need to implement area and perimeter, but I would be using rectangle area and perimeter. So now, with just this kind of definition, I can create square. Let's say SQ is equal to square, and I just need to pass only the one side length. And let's just print area of square. SQ1 area. See, and we got 25. So this is the benefit of object-oriented programming. You can reuse a lot of your code using inheritance and abstraction. So you saw I already had few implementation. I just wrote an init method, a constructor, and that's it. And I have a square shape available with perimeter and area and everything. I don't need to define any special thing here. So this was a good overview of how you can implement object-oriented programming in Python. But you would need to practice a lot. You would need to practice. You need to take small use cases, create your class diagrams, and then you start writing your code. So generally, this is how it works. You decide your classes depending on the application you have. You create your class diagram. You create all the relationship. What would be child, what would be parent, how many parent you would be inheriting, what are the attributes that you want to inherit, what are the attributes that you want to make private. Okay, so we have not seen that private attributes, right? So let's say I am defining a parameter. I am defining a parameter, but I don't want anybody to use it directly. So for example, if I say self dot underscore underscore and variable name. Now all the variables that I start with underscore underscore, they are not available outside my class. Even object cannot access it. So if I say print sq dot length, it is available. But I cannot print sq dot underscore underscore private variable because this private variable it is available only within the class. Not even the object can access it. So what is the use of it then? The use is I don't want anybody to directly change this variable. This is very important variable for me. So what I would do is, or maybe this is just a read only variable. I don't want anybody to change it. So what I can say is get private variable. I'm writing a method and I say return self dot underscore underscore private. Now, if somebody wants to access or read this variable out of the class or object, he can use this method. So using this method, he can only read it, but he cannot change it directly. So this is how you can make variables private in object-oriented programming. So again, as I was saying, you need to practice this thing on because this object-oriented paradigm takes time. You would have to write yourself and design few applications to get hold of this. But once you get hold of this, this is very helpful. So in the next session, we would write a small application, a small program, a banking application that would make things clear. So keep tuned. I will be sharing that application very soon.